Hello, everyone. It's a pleasure to chat again with Deepak Bansal. Deepak is a corporate vice president in Azure, responsible for much of the software and programmability portions of Azure networking. Deepak has degrees from MIT and IIT Delhi before that. And a little known fact is that my PhD thesis advisor and Deepak took many of the same classes in graduate school. And I've heard a lot about Deepak. Apparently, Deepak used to walk on water even then. Um, Deepak, say hi to everyone.
Yeah, hi everyone. Thanks, Srikanth, for such nice words. Really excited to be here and chatting with you about network disaggregation.
Wonderful. So let's get started. Deepak, could you tell us a little bit about disaggregating network functions? I know you and your team have spent a fair bit of recent quality time on this.
Yeah, so when you look at a cloud, a public cloud, we have lots of different kinds of workloads that run in the network cloud. And these workloads have very different requirements on the CPU side, on graphics processing, and on the network, right? On the network side, a set of functions called network functions. These are your firewalls, your intrusion detection system, your proxies. These are critical part of any infrastructure's deployment in a public cloud. And these functions, they tend to be more network intensive than your typical application workloads. And so these network functions, when they're running in the cloud, they require the cloud to provide them much higher level of network performance than a typical application running on the cloud. Now, what that means is the underlying hardware that they're running on, that hardware needs to be able to sustain those kinds of network throughput. And when I talk about network throughput, I'm not only referring to the packets per second, but the traffic that comes out of these network functions, they need to be processed and various policies need to be applied. For example, network address translation may need to happen, layer 4 stateful ACLs may need to be applied, and various other packet manipulations that may need to be done on the traffic that is coming to and from these network functions, right? Now the cloud hardware, it's optimized for the most generic workload, right? Because that's where the commoditization and that's where it can be most cost efficient, right? What that means is this network intensive workload, when it is running on this commodity hardware, it may not be able to get the kind of network performance that it desires. And traditionally, we have tried to overcome this problem by scaling out the network intensive workload. So rather than running it on one VM, run it on many VMs, and the number of VMs that you need to run it on has to be increased significantly large because of the bottleneck in the network packet processing. The CPU may not be used much at all, but it's the network processing bottleneck in the infrastructure provider side that becomes the bottleneck. So the solution for this is not to build a bigger server with much higher network capability, because again the challenge is cloud is about commoditization and workload running on any server in the data center. So you do not want to provision all the server with higher capability when only a small fraction of the workload in your data center, the workload that is in the running network function, needs that kind of performance. And disaggregation is the standard solution for this kind of highly variable workload, where you want to optimize your general fleet with the average case, and then for the scenario which requires performance much higher than the average case, you throw additional network processing at it through hardware that is sitting somewhere else in the data center and on demand gets leveraged for the specific VMs that are running these network functions. So network disaggregation helps us deliver high network performance for any VM that may be running a network function without having to deploy hardware on each and every server that is able to handle that kind of network workload.
That sounds really cool. So the peak versus average case really stands out, and I'm sure you'll get both cost benefits and maybe functionality improvements as well. I was just curious, like, what are there some key technical advances that's making this feasible, that's making the disaggregation of network functions more feasible now?
Certainly. So if you go back, right? First of all, the bandwidth of the network has been increasing, right? We are um, past 40 gig, and 100 gig is going to become commodity in next few years, and that's aggravating the network performance bottleneck that is being hit at the host on which the virtual machines are running. So that's one of the big pushes towards network disaggregation. Then you look at the other side, we have network hardware coming out that is far more programmable. P4 is a very widely understood programming language in the networking industry that has become quite standardized, and it enables the hardware to be programmed such that it can do those kind of advanced packet processing, the layer 4 SNAT or network ACLs kind of packet processing at line rate in hardware, but the hardware is programmable. So as cloud environments require new kind of packet processing for these network functions, this programmable hardware can easily be configured for a specific network function or for various kinds of network functions that may exist in the data center, right? So it's a combination of higher bandwidths that's driving the needs towards network disaggregation, as well as the new hardware that's becoming available in great price points, and then the ARM cores that are relatively cheaper. So ARM cores combined with these programmable chips that can offload network packet manipulation at line rate has made network packet processing in hardware really available and possible at high line rates, which is making the network disaggregation possible now.
Yeah, that makes sense. Better connectivity, better hardware, very more programmable hardware that can support a lot more functions in it. That sounds awesome. But disaggregation also makes some things harder, right? Like how would you handle application failover? How would you handle enhanced security?
Yeah, so certainly disaggregation sounds awesome and sounds like this magical technology that if we could disaggregate everything, why wouldn't we? But there are several challenges in terms of deploying this new architecture, right? First is the capacity provisioning of this disaggregated hardware, right? How much capacity do you need in the data center for this kind of specialized network processing hardware? Second is, how do you send the traffic to this disaggregated hardware, right? You need some capability in the host to be able to dynamically route traffic for certain VMs, which are network intensive VMs, to the disaggregated hardware, whereas for your other VMs which are not network intensive, those packets can be processed at the host itself, because you do not want to be sending all your traffic to the disaggregated hardware, because then that becomes a choke point or a bottleneck point. And then of course you have challenges around high availability, right? The disaggregated hardware can fail, and while a server fails, the impact is only to the VMs that are running on that server. But if the disaggregated hardware fails, then it could potentially impact large number of VMs that are all you're pointing to that disaggregated piece of hardware. So you need high availability solutions where you have multiple of this network functions or network hardware running in the data center, and ability to route traffic dynamically from one appliance to another appliance if that appliance were to fail. Another set of challenges come around security. So customers often want their traffic encrypted from the source to the destination. Now this network appliance is sitting somewhere off the host in the path of the network. So you need to the ability to be able to intercept that encrypted traffic, be able to inspect it and take corrective actions. So there are those challenges that exist. And last but not the least is this technology is still relatively new, the layer 4 programmable packet processing hardware. So a lot of research and development is happening in that area to squeeze the maximum performance, to implement all the capabilities that we need over there, and to overall mature the technology. So those are some of the challenges that we face towards network disaggregation.
Yeah, this sounds very interesting. But abstracting out a little bit, it almost seems like having this box on the wire, which kind of defers some some network functions, and is quite programmable, could let us do other functions as well beyond just doing things that we might be doing in a less efficient manner in the host. Could you speak to like where you see the future with a disaggregated NF?
Certainly, Srikanth, there is so many scenarios that we could light up with this disaggregated hardware. Today, if we have to roll out a new feature, we have to roll it out on each and every server in our fleet, because the VM that may be needing that feature or the network function that may be needing that feature could land on any server. But with a disaggregated piece of hardware, we just need to enable that new feature in that disaggregated piece of hardware, and we do not have to touch our entire fleet. An example of this is multicast, right? Multicast is one of those technologies that is widely used in financial markets to fast deliver a ticker symbol out to the various destinations. Now, not every workload needs multicast, right? Very few workloads running on the Azure platform needs multicast, and there is no need for us to roll out multicast capability on each and every server in our data center. We could deploy it on the disaggregated appliance and make it available to the VMs dynamically as the customer may require. There are several scenarios in the edge space as well, right? Here we are talking about 5G, when customers are deploying Azure in a box on the edge, where you are space constrained, and the amount of server hardware that you may have available may not be as plenty as in a public cloud data center. In those scenarios, you want efficiency of packet processing. And this is not just about network functions on top of it. You can also think of scenarios like video compression or data analytics, data compression. For those scenarios, having a programmable hardware that could be programmed to do specific functions in a very cost-effective and power-effective way is going to be so critical and so useful. So this, we are just getting started on network disaggregation, right? Over time, I see network disaggregation becoming a fundamental Lego block in any data center or edge architectures, such that we don't have to burn the CPU cycles of the commodity servers. They're meant to run application code, and these network disaggregated appliances are meant to do the packet processing, things for which we do not need to consume the CPU cycles, so that the applications can perform well, and they don't have CPU cycles being stolen away from them just doing packet processing.
Yeah, that sounds cool. So I want to shift gears a little bit. For you've had such a storied career, so I was wondering if you could, take a minute or two to tell us, to tell me and the audience some lessons that you've learned, both technically and personally, things that you would wish, more people knew earlier in their careers. Yeah.
Sure, that's always a fun question, Srikanth, and there are scars from building and running the cloud over the years, as well as key insights that I've learned over the years. The first thing I'll say is around is around being customer focused and scenario focused, right? There are many technologies that will come and go, but unless there is a critical need or a critical scenario that you have identified where that technology can fit in, the technology is there for the technology's sake, right? So, so be very rooted in the customer scenario, and understand your workloads, right? Second thing is, you know, don't take no for an answer, right? Over the years, right, like even with this disaggregation, right, there are people who will say, hey, well, Nitro running on commodity servers is proven. AWS does it. That's how it is done. Why do we need network disaggregation, right? And I have heard that story multiple times through my career where there is an existing solution which was perfectly fine for the scenarios that existed when that existing solution was built. So it's not like someone built Nitro wrong or someone built an existing system wrong, but the scenarios have evolved, right? And the technology have evolved. So it's a combination of evolution of scenarios and a combination of technology evolutions that may make a given solution more valid now than few years ago. And people will often quote you like saying, hey, this is already exists in production, has been working for a while, why disrupt it? What's the need for the disruption? So don't let that hold you back, right? And then once you identify the scenario and you identify the technology disruption, run with it. Don't stop. At that point, you have absolute clarity. Others probably around you will not have as much clarity, but just with your steadfastness, with your focus, you can prove to others, and slowly but surely the others will start recognizing the value and the need, and they'll all come along. So that's what I'll say are some of the key learnings that I've had over the years. One more I'll add is reliability and scale, right? Think of that from day one, right? Operations, reliability, and scale, right? For any technology to be deployed in the cloud, often the hardest problems are in that space, not in getting the solution working, right? You can build a demo app with all the blocks, the building blocks, relatively quickly. The challenging part is in operating it at scale, operating it with high reliability, and unless you're thinking about it upfront, it catches you by surprise, because once the ship has taken off, there is no stopping it. Then you're either playing catch up to it all the time, or you're in the driver's seat, and you would want to be in the driver's seat to have fun, because sitting hanging by a thread once the ship has taken off is not fun, right? You're worried about getting crushed anytime. So you want to be in the driver's seat, and to be in the driver's seat, plan for success, get reliability and operations nailed up front.
This was awesome. Thanks again, Deepak. Thanks for taking the time to chat with us. Yeah, many thanks.
Yeah, thank you, Srikanth. It's always fun having a chat with you and sharing what we are seeing in the cloud space and where the industry and research can help us. There is a lot of great work that the research community has done in building P4. There's a lot of work that's happening in the industry around programmable hardware. There are a set of APIs called Dash APIs, disaggregated APIs for Sonic hosts that we open sourced last week. I'll encourage folks listening to this chat to go check it out. But there are several companies out there, Pensando, Fungible, Intel, NVIDIA, that are very active in this space, and we are really grateful for the industry taking this problem head on and helping us address this problem.
Cool. Thanks again. Yeah.
Thank you, Srikanth. Bye.